Hi everybody, how are you? My name is Faraz Yusufi, and today we're going to be talking about acids. So the roadmap we're going to follow for today when we talk about acids is first, what is an acid? Secondly, we're going to be talking to you about what the difference between a strong and a weak acid is. Thirdly, we're going to be talking about properties of an acid. And finally, fourth and last, we're going to be talking about the chemical reactions of acids. So the first question is, what is an acid? An acid is any chemical substance or molecule which, when added to water, will dissolve to produce hydrogen ions. So again, any chemical substance that again dissolves in water to produce hydrogen ions, we call an acid. Now, think about sulfur dioxide gas. Unfortunately, when we get SO2 into the atmosphere as a pollutant, as it's floating around us, it is not harmful. It's only when we breathe it in and it gets into the water on the inside of our body that it starts to become harmful. Because once it gets into that water, as it breaks apart, as the water molecules break apart, they produce hydrogen ions, which cause the acidity and the properties that result from that. Also, think about battery acid, H2SO4. As a pure form, H2SO4 is a liquid. Does not have any properties that exhibit acidity. But the moment we put it into water, the moment we put it into an actual battery, it starts to conduct electricity exactly like an acid should. Again, implying that it is the water that causes the acidity to hold true. The thing that you want to remember is that an acid is only an acid when dissolved in water. Now, there are two types of acids that we're going to discuss. The first of which is what we call strong acids. The second we call weak acids. Now, our strong acids are those molecules that fully dissolve into water to produce hydrogen ions. Our weak acids, on the other hand, are those molecules that only partially dissolve to produce hydrogen ions. So an example of a strong acid is a battery acid. Because again, in battery acid, all of the molecules when put into water fully dissolve. And that's what causes the actual battery acid to be so harmful, because there's so many hydrogen ions present. Whereas in vinegar, when we give you 10 molecules of vinegar, only one of those will dissolve, thus allowing that vinegar to be a lot safer and a lot less acidic. That's why we call it a weak acid. Now, let's talk about the properties of an acid. The first property is the pH level. Now, what is pH? Power of hydrogen. It simply measures the number of hydrogen ions in a solution. And the hydrogen ion concentration is inversely proportional to the strength of an acid. And for example, the higher the H+ ion concentration, the lower the pH of your solution. Any solution that has a pH less than 7 is an acid. Now, the second property is a litmus paper. Now, what is litmus? Litmus is an indicator. An indicator is any chemical that changes color once put into an acid. So litmus, for example, initially is a blue-colored piece of paper. But when you put it into an acidic solution, litmus turns red. Now, the third property is that acids act as electrolytes. Now, what is an electrolyte? Any liquid that conducts electricity due to freely moving ions. Now, remember when we talked about earlier acids dissolving in water, we said that they produced ions. So think of battery acid as an example of an electrolyte. Until you put battery acid into the battery, the conduction of electricity does not occur. It is because of that liquid being present and the ions moving within it that a battery is able to conduct electrical energy. All acids are electrolytes. Now, let's talk about the chemical reactions of an acid. So the question is, why do we have chemical reactions for acids? Well, simply because the H+ ions present inside of the acid have to be neutralized. So these reactions give chemical materials that will help to neutralize or use up the hydrogen ions of an acid. Now, for example, let's take battery acid, which is a strong acid, vinegar, which is a weak acid, and let's put equal amounts of magnesium into both. Now, what's going to happen is that as the magnesium reacts with the hydrogen ions of the acid, as it neutralizes the hydrogen ions of the acid, you're going to see the magnesium disappear, and you're going to see bubbles of hydrogen gas rush to the surface. In the strong acid, in the battery acid, because the magnesium neutralizes the hydrogen ions more quickly, you see a more rapid reaction. Whereas in the weak acid, because there's less hydrogen ions present, the reaction, the neutralization occurs much more slowly. All right, the second property of acids are that they also react with metal carbonates to form salt, water, and carbon dioxide gas. So for example, when we take ENO for acid indigestion, ENO is what we call sodium bicarbonate. It's a compound that contains carbonate ions. And the reason why we take it is when hydrogen ions build up in our stomach or in our esophagus, it causes a burning sensation. So when we take that ENO, it goes in and it neutralizes the H+, and the reason why we burp at the end is because carbon dioxide gas is escaping from our body. So again, you're going to see a second property where metal carbonates also neutralize acidity and get rid of H+ ions. The third example we can give you is the third chemical reaction, which is metal oxides can also neutralize acids. For example, milk of magnesia has very much the same effect as ENO. When you have acid indigestion, instead of taking a powdered form like ENO, you can take a liquid form of milk of magnesia, which contains magnesium oxide, a metallic oxide, which also neutralizes the acidity in our body. This forms a salt and water. You don't burp this time because gas is not being given off. So again, you're seeing acid being neutralized by two other substances, a metal carbonate and a metal oxide, which we both refer to as bases. So the next topic we're going to talk about in the next lesson, we're going to introduce what a base is. So we gave you an idea of neutralizations of bases with acids. We're going to go into specific details of what a base is and those that dissolve, which we call alkalis, and talk about their properties. Thank you, everybody.